Assalamualaikum guys. So yesterday also I have given the question right, so none of them sent. So yesterday's class also it's made as like that because of the unavoidable situation. I want to go to school, so that's like I don't able to do the class. Okay, fine. So I will do the continuation of what the fortnight examination paper. Then after that I will start. If we have time, I can start the yesterday's question. So the yesterday's question I already said it belongs to what the unit 4, right? So unit 4 basically we couldn't find the separate MCQ. It's hard. Recent question you never find because it's always combined with what? Equilibrium. I already said yours, right? So I have found some question and just do the paper. Sorry, do that question unit 4, right? So guys, there should be only 2 or 3 questions. Inshallah, hopefully after we finish, we can move on to the unit 5. So before that, let's we start what the fortnight examination paper. So let's redo the paper. Question number 5. The ideal gas equation can be expressed in the form of the pressure is equals to rho into RT, okay, over N, where they said the rho is density of the gas, M is a capital M is a molar mass of the gas, without the statement also you should be able to say R is a gas constant, capital T is the temperature. Just you want to find the unit. This is what you used to do in where? In your physics, right? The pressure is you're giving by Pascal, right? Okay. Temperature is Kelvin, even though if they didn't say, you should know that one. And the gas constant is always is given in your paper. The value is there, so from that you can extract the unit, that is joule, Kelvin minus 1, mole minus 1. And the molar mass, you know that one, that is also you know gram per mole. So these two only they have given, and these you should know. Even though if they didn't, you should be able to find it, right? If units of, yeah, they have given the gaseous constant also. So let's find the density. You have to find the unit of, I'm sorry, you have to find the unit of the density. It is a pressure. Pressure is the Pascal, right? So for what? For that sake, what you want to do is first subject the density. So this is what P is, pressure is equals to density into gas constant into temperature, which is divided by the molar mass. So let's be subject what the density. The rho is equals to, yes, pressure into molar mass, which is divided by gas constant into the temperature. So this is very important, right? Before you start, I will show you one thing. Okay, you can notice the answers given. Why I given this answer? Without the answer you can find it, but the answers are very important because they say the pressure in the Pascal, but here you won't see any Pascal. I don't know whether you noticed. So can we see the answers? Kilogram, meter minus 3. Gram, meter minus 3. Gram, centimeter minus 3. Gram, decimeter minus 3. Kilogram, centimeter minus 3. So from these, we know the Pascal couldn't come. So what is the alternative unit for the Pascal that we are using? Even though they said Pascal, you can say that is as what. You should know that one. So that is what is, guys, I'm telling you all. The Pascal you can say as Newton meter minus 2. Okay, so now the pressure, you can put the Newton meter minus 2 into, yes, molar mass is gram mole minus, which is divided by joule, Kelvin minus 1, mole minus 1, and the temperature is also. The Kelvin will come out. Okay. Okay, so be very careful. And look at here, the mole will come out. Now your answer is Newton meter minus 2 gram. This is divided by 2. Have you all checked the answer? There is no joule. What you want to do is, you have to find the alternative value for the joule. The joule is given by Newton meter. You have studied in your physics and you should know about these units and everything. So I'll delete, I'll erase this part of it. So what are you trying to do? No, right? The density is equal to Newton meter minus gram, which is divided by joule. The joule can express as a Newton meter. Now the rho is equal to Newton meter minus 2. Newton meter minus 2 into gram. Divided by again another meter. This will cut off, this will cut off, the meter will come up. So you will get gram meter minus 2. Let me check the answer is there. Yes, the answer is there. That is number 2. So this is very important. Why we are doing the MCQ as well as what you are expecting. If it is just a question, you can give this answer. Okay, not only this answer, you can see, you can give this. Either you can end up with a Pascal. It doesn't matter. We know the gaseous constant and the molar mass and the temperature. That should be, molar mass and the temperature. That should be the same value. But you can substitute for the Pascal either Newton meter minus 2 or Pascal. To the pressure either Newton meter minus 2 or Pascal. So what they said, according to that, you should be able to for the Pascal, but you should be able to check your answers. According to the answer only, you have to decide what is the unit that you want to substitute, right? So we have completed that MCQ session. So let's say move on to the structured essay in the fortnight examination. right? They are telling is your first part. What is happening? The 25 centimeter cube of this solution was titrated with, yes. Yes. The 25 centimeter cube of this solution was titrated with 0.05 m potassium permanganate solution. So the end point of the KMnO end point is 24 centimeter. Right. The solution obtained after completing the titration 1 was further titrated. You should be able to understand. So this is what is happening actually here. Let's we draw the diagram. Okay. So what is happening? They are titrating with what? KMnO4. Right. This is your titration class. It's already you have the Y solution. The Y solution having what? Dilute sulfuric acid and oxalic acid. Now they titrated. They end up with this results. Right. Now the second procedure. They are taking this plus, the titrated plus. You should be very careful about that. When you say the titrated plus means it should have what? Sulfuric acid, balance oxalic acid, so oxalic acid also all together is finalized. So you can say the excess KMnO oxalic acid all should be there. Okay. So now what they are telling is it is followed by after this titration. For further titrated with, right, they have further titrated with titration plus, they have carried the reaction 0.04 m sodium hydroxide solution, and they said the end point. So when I said the end point, right guys, you should be able to understand what is that volume. Yeah, either that is what, yes, when you speak about the end point means what you have taken in the burette is it's meaning the end point. This is what the burette. Okay, this is the burette. So according to that only you should be able to speak about the end point. So again I'll just recap this question. Your solution Y is having what? Okay, just again try to understand this question. Look at your Y solution is containing what? Dilute sulfuric acid with oxalic acid, right? They have taken what? The portion of what? 25 centimeter cube of Y solution. Yes, the Y solution is 25 centimeter cube. Then they follow what? The titration. Yes, the titration. The titration is held with what? 0.05 m permanganate solution. Right? You should be able to understand that one, right? So that should be the permanganate solution. Now the titration has finished. So the end point is observed. So what is the volume? The end point means what? The volume of, yes, permanganate, right? So the permanganate is 24. Now what they had done after this, the first titrations finished, they have taken that class and they followed another titration. So that is they took, you have to be able to understand the titrated flask. The titrated flask either containing the acid, sorry, excess acid is there. Yeah, your acids of what? Oxalic acid should be there. Acids, I'm talking about acids. But here, If you add one or more drop of the KMnO4, that should be there. Sometimes it could be negligible, and you doesn't have the oxalic acid. Why the oxalic? All oxalic acid is neutralized by what? The permanganate ion. So excess acid was. So you should understand what they have had done is this. The excess acids or whatever the acids present here. It's titrated with a base, sodium hydroxide. This is the endpoint of what? Sodium hydroxide. And they have obtained this value. So now we are going to perform the reaction, and with this you should be able to understand what type of the reaction is this. This is, we are telling, redox titration. You should be able to see without antagonists, right? Okay, let's start the discussion. The first question is clear or wrong, right? Please keep what I said and just try to understand the question, then listen. The first question is, write the balanced equation for this reaction. Yes, guys. This is, I already said it. What is that? Is this is redox titration. So the reaction should be the redox. So what is happening? You are using the permanganate ion, right? So the permanganate ion in acidic medium, what will be happen? It will come as Mn2 plus. And yes, under acidic medium, always oxalic acid C2O4 2 minus. You have to write in the ionic equation first, and that should be end up with what? CO2. And guys, you should be able to understand. First, the redox titration method is what should be the oxidation and the reduction reaction. What is mean by the redox reaction? The combination of the oxidation and the reduction reaction is we are calling the redox reaction, right? So first, we'll check the oxidation number of these two, and we'll find one by one. So manganate, MnO4 minus, yes, X plus minus 8, which is equals to minus 1. Therefore, X is equals to plus 7. So the manganate is plus 7. And manganate is plus 1. It is become as a manganate is Mn2 plus 7. The number of oxidation number is decreasing, therefore you can say this is reduction reaction. And take C2O4 2 minus. Look at here. Again, oxygen. C2 is a 2x. Oxygen, yes, minus 8, which is equals to 2 minus. So the 2x is equal to plus 6. X is equal to, yes. This is up to you guys. Able to find this. Here, the x is equals to, and here x is equal to plus 4. How? Okay, again I will do x plus minus 4, which is equals to 0. So x is equals to plus 4. So what is the number of oxidation number is increasing. So this is oxidation reaction. Now let's say write the redox reaction. So take your manganese. So I will raise this carbon dioxide and will perform for the manganese. So let's say do for the manganese, right? Shall I raise this part also? You know that is plus 7, we'll keep this is plus 2, and let's say write as that. reduction reaction. So the reduction reaction, this is plus 7, this is plus 2. So the first thing is you have to check the number of manganese is 1, 1. That is right, 1 is to 1. And what you want to do is, second, you have to check, yes, the oxidation number. Here plus 7 is plus 2, so we have to balance the oxidation number. So we are adding 5 electrons this side. So this is plus 7, this is minus 5, therefore this side also plus 7 oxidation and this is also oxidation. The oxidation part is completed now. Right. And let's check the total charge. Check this side. Yes, this is minus. This is 5e also minus 5. Altogether you have the total charge is 6 this side. And what about here? So let's raise and do, then it will be a clear impression for you. Okay, right. And you should be very careful about that. Now I am talking about what the charge decides. This is the what? There's manganese as a minus, manganese ion, and this is the 5 electron means what? That is also minus. And this side as well, as we know, the total charge is plus 6. This is minus 6. So what you want to do is you have to neutralize the charge first. So you have to get what? The plus 2. That means you have to reduce into the 0, then you have to move to the plus 2. Therefore, from the minus 6 to 0, you have to add plus 6. To become again plus 2, you have to add another plus 2. Altogether, you have to add the plus 6. So, how should be? For the positive charge, we are adding, yes, hydrogen ion, right? Now, okay, the both sides. This side you have the oxygen, this side you have the hydrogen. So now you have to balance the hydrogen and oxygen both sides. Yes, now you have the 8 hydrogen, therefore you can add the 4 H2O liquid. The 4 here also 4. Yes. Now this reaction is balanced. Okay, I have done this one. Okay, let's move on to the oxidation reaction. So when you take the oxidation reaction C2O4, sorry, 2 minus, it's becoming as what? CO. So first you have to check here 2, here 2. We already said this is plus 3, 2 plus 4. Here 2, there is 1, so you have to make it 2. So that means what? You should be able to understand here. So 2 into 4, yes. Again you have to balance what? Yes. The oxidation state. Here only for 1 carbon I said 3, for the 2 carbon plus 6. Here also 2 carbon plus 8. So what you want to do is you are adding 2 electrons this side to make it to the plus 6. Now check about the oxygen. Yes, O4, O4, that is also okay. And check your charge now. So when you check the charge, when you take the charge, right, you check your charge. Here 2 minus, and this side also, this is 0, this is 2 minus. That is also balanced. And you have the oxygen also balanced. We are not able to add but the hydrogen, so this reaction is that much. No need to balance here. Now we found the oxidation and the reduction reaction. Now you have to, what you want to do is you have to combine together. So you should be very careful about that. Yes, okay. This is equation 1, this is equation 2. So first thing, to combine, to combine the reaction, check here. Here you have what? 5 electrons. Here you have the 2 electrons. The electrons should be equal. So what we are doing is, your equation 1 is multiplying by 2 plus your equation 2 is multiplied by 5. Right? Should be very careful about that. That equation 1 is multiplied by 2. That equation 2 is multiplied by 5. So what you want to do is, now the equation 1 is, now we are add together, right? So now you want to add together. So equation 1 is multiplied by 2, right? That is what permanganate MnO4 2 minus, it will become as a 2 plus 8H plus will become as a 16H plus, and you know this is the 10 electron. I will write as 2. And this side you will have the 5 C2O4 2 minus. And equation 1 Mn2 plus, yes, 2 plus 8H2O. And this side, yes, 2 into 5, 10 CO2 plus 10 electron. So you can see the both sides having the electron. Then you can cut off that one. Sorry. This should be 10 electron, and this is also 10 electron. You can cut out. So your equation is 2 permanganate 16H plus 5C2O4 2 minus oxalic acid 2 manganese Mn2 plus ionic equation is enough 8H2O and then carbon dioxide. So this is what we have to do. Very simple. No need to explain this much, but if you know that one, it doesn't require. Okay. And let's move on to the next question. You have to calculate the concentration of the oxalic acid. The first step is you have to find the concentration of oxalic acid H2CO4. So we know here, right, when you take the volume of permanganate, yes, what is the volume of the permanganate? Yes, you should be able to say that one. Okay, sorry guys. So I was searching the volume. The concentration of the KMnO4. The KMnO4 concentration 0.05 mole minus. Now, from the equation, you can find that is what? The permanganate, the ratio between the permanganate and the oxalate ion. Right? What is the ratio? That is 2:1. Let's find, yes, the moles of permanganate. So, right, you know the common equation, the C is equals to N over V. N is equals to C into V. We know the volume and everything. So, the volume, the concentration is 0.05 mole decimeter minus. And the volume is 24.0 centimeter cube should be converted into the decimeter cube. 4 to the power of -3. Your answer is That is 1.2 into 10 to the power of minus. And I said about this ratio, right? So you have to find the ratio, the moles of oxalic acid or oxalate ion. So how would you do this one? I say the 2 moles of permanganate ion is containing 1.2 into 10 to the power of minus 2 moles. What is 4? Yes, 5 mole of oxalic acid. This is the way you have to substitute the answer and it is the 2 mole of the permanganate is containing actually this amount of mole. What is for the 5 mole of the ratio you have to do that. So what is the answer is 3.0 into the power okay. Now you want to find the concentration of oxalic acid, right? I'll take this one. This area. That is enough for me. I'm going to take another color. Okay, so I want to find the concentration of the oxalic acid, right? So you should be able to know the concentration mole divided by the volume, right? Okay. So what they had taken in your class, titration class, that is 25 volume. You have to convert into the decimeter cube into the power of minus 2. That mole is what we have found here. 10 to the power of minus 3 will cut off your answer at 0.12 mole. So it should be easy. You think in a proper way, right? So the titration means what? The finding the unknown concentration by using the known concentration of the solution. That is what we call in the titration. So this is the standardization as it happens. But what you want to know is by using that endpoint volume and the known concentration of the permanganate ion, you can find the mole of the permanganate ion. So now we found the permanganate ion moles. And we know the ratio by balancing the equation. That is very important. When you do the redox titration, you are able to balance the equation first. According to that equation, right, you should confirm, right, 2:5 ratio. And we know the mole also, actually what happened, what is inside your class. Then I just went with the ratio. Your 2 moles of the permanganate ion is containing this amount of moles now. What is for the 5 mole of the oxalic acid? And I found the answer, that is 3.0 into 10 to the power of minus 2 moles. Okay, and let's we move on to finally you have to find the concentration, and for the titration class you have taken, guys, you should be able to understand that one. So you have taken, that is the 25 centimeter cube. So what do you want to do? Just say no will be substitute and just take the. You should be very careful about the units here. Whenever you get the centimeter cube, you have to convert into the decimeter cube. The decimeter cube simply I'm just multiplying by the 10 to the power of minus 3. Okay. You can divide by the 10 to the power, 10 to the power of 3. Okay. So let's move on to the next question. So this is easy. The next one is seems to be complicated, but I already explained what is the question is thinking. Right? You have to find the concentration of the sulfuric acid in your Y solution. This is what you have to find. So let's do one thing. Right? They have taken, I said, from the titrated flask. The titrated flask is containing what? Y solution. The Y solution having oxalic acid, yes, and the sulfuric acid. And that titrated flask is oxalic acid is already titrated, but H plus is available. I said right. So sulfuric acid has the H plus, and the oxalic acid also having H plus. Now I'm going to speak about that. So you have found what the endpoint for the sodium hydroxide. What is mean by that? The balanced acid is neutralized by what? The sodium, total sodium hydroxide. So what is there? To find the moles of the H plus left into after the first step. This is very important. You have to find the concentration is available there. So the balanced one. You have to say the moles of H plus left after titration 1. So we know, yes, what is the mole of the concentration of what? Sodium hydroxide 0.04 mole decimeter minus A, and the volume is 15 into 10 to the power of minus 3 decimeter cube. And I found the answer is 6.0 10 to the power of minus 3. Right. And you should able to the moles of the H plus used in this step 1. Yes, what is that ratio? So yes, for the 2 permanganate ion, okay, I will write like this. The permanganate ion is to H plus. 2 is to 16. So therefore 1 is to 8. And you know the concentration of the permanganate ion is, you already found that is 1.2 into the power of minus 2 mole, the mole of the permanganate ion. So what you want to do is, yes, your 1 mole of the permanganate ion is containing 1.2 into 10 to the power of minus 3 mole. What is for 8 mole of the acid? So you will end up with that is answer. Just will keep like this. 1.2 into 10 to the power of minus 3. Okay, I'll write it in front of that. That's part also. The next, the moles of the oxalic acid. I used to say the oxalic acid having the 2H. So the mole of H plus from the oxalic acid. So what do you want to do is, we have found what? You have the 2H plus here. How many H pluses here? You have the 2H pluses here. 2 into. And we have found what? The mole of the oxalic acid. 3 into 10 to the power. 6 into 10 to the power. And we all found these things. Again, I'm telling, just go for that, right? Okay, I have found the moles of the H plus after left, right? After the first titration, that what is neutralized by the sodium hydroxide, so indirectly I have found that is 1:1 ratio. Okay, and next the moles of the H plus used in the step 1. Yes, the permanganate in the, what is the ratio between the permanganate and the acid, that is 2:16. Then you can take the simplest ratio, that is what? Yes, 1:8. Right, from that you can find, you know, the mole of what? The permanganate ion. So ultimately I have end up with what? That value. And the moles of the H plus, I said, yes, your oxalic acid also is containing 2H. So 2 into your mole of the oxalic acid, oxalate ion, right? That is also. Now your part is, we have to write the equation. The amount of H plus H2SO4, which is equals to the amount of H plus remaining after step 1 plus amount of H plus used in step 1 minus amount of H plus from oxalic acid. Did you understand this? You have to find what the moles of the sulfuric acid, the moles of the sulfuric acid. And I know they have taken the titrated flask, having the oxalic acid, right? And the excess sulfuric acid, okay? And the amount which is used to that sulfuric acid also we have to find. Why? The excess sulfuric acid after the titration, that is neutralized by what? The sodium hydroxide, right? That sodium hydroxide, then you can say, right, that is there. And the amount of is used up, so that is also we needed, which is taken from what? The sulfuric acid. But that is very important. This H plus, this acid is, it came from whom? It's oxalic acid. Oxalic acid is not contribute for the sulfuric acid, so you have to deduct it. This is what, that's all. Now substitute the answer what you have taken. 6.0 10 to the power of minus 4 mole, right? Plus 8 into 1.2 into 10 to the power of minus 3 mole. Minus, yes, we have found that is again 2.3. Okay, I said and ultimately you will end up with 4.2 into 10 to the power of minus 2. And now you should be able to say one sulfuric acid is containing the 2H plus. So the number of moles in 25 centimeter cube of solution. So that is what the 4.2 into 10 to the power of minus 3 mole. We said the sulfuric acid 2 is there, so we have to find equals to 1. So that is 2.1 into 10 to the power of minus 3 mole. Now what you want to do is finally you have to find the concentration. So the concentration, we know the volume, right? So shall I write down? Yes. C is equal to N over V. You know the concentration, that is 0.1 into the power of minus 3 mole, which is divided by 25 into 10 to the power of minus 3 decimeter cube. Your answer is 0.084. Okay, so you should be able to understand, right? So this is how we are doing this. And thank you very much, guys. Inshallah, I have completed the fortnight examination paper. So tomorrow, please attend the class. I will start to do the paper what I have given the yesterday's session, right? So inshallah, I will discuss that one. Until I see you. Bye bye. Assalamu alaikum wa rahmatullahi wa barakatuh.